Assalamualaikum and good morning, Doctor. This is the video for our presentation about reengineering with reflection models, a case study. This is our group members, Najma, Faris Nazrin, Taufik, Salma and Abhinesh. Next. Okay, firstly, we will start by defining a new terms that we found in the case study. Okay, the first term that we can find is reflection models. The definition is a reflection model is the technique used by software engineers to identify the reflection in a large body of source code. Either they can identify the selected high level or the structural view of the system from the source code. And this next term is a bottom-up reverse engineering. Bottom-up reverse engineering is the method where source code is analyzed and the abstraction of the system are produced using automated and semi-automated techniques. Next, top-down reverse engineering. Different from the bottom-up reverse engineering, top-down is breaking down of a system to gain insight into its compositional subsystems. Next, the automated technique. It is a technique used to identify the structural high-level components of the code by applying either numerical methods or knowledge of structural patterns. And lastly, semi-automated technique, where human is more involved in it compared to automated, and the user can select information of their interest from the source code and cluster it to gradually develop a high-level model.
Okay, the next one is motivation, which is why we need the re-engineering with reflection model. Okay, first, if you see, okay, tool supported re-engineering is based on bottom-up reverse engineering approaches, which Taufik mentioned earlier. It is which the source code is analyzed and the extraction of the system are produced using automated technique and semi-automated technique. Okay, as mentioned earlier, automated technique is identify structural high level of component by applying numerical method or knowledge of structural pattern. And semi-automated technique, which is user more involved in selecting information which from the source code and clustering it, which mean we involve user. And then we can gradually develop a high level model. Okay, next. Okay, so what's the problem with this? Okay, first, the automated is based on pre-coded structural source information, which is it will limit when the re-engineering task require other information. And also the semi-automated, which tend to become increasingly hard to apply because the information extracted from the source will grow. So, with the automated and semi-automated, then will result to limitation to handle the real-world re-engineering tasks. So, because of this, we combine the top-down approach and bottom-up approach. This is the technique, the reflexion model. So, the software engineers can quickly form hypotheses from the variety of sources and then concentrate their effort on getting information about the part of the system that are relevant to the task at hand. Okay.
Then now we will talk about the technique overview. The software reflection model technique has been used to support design conformance tasks and to assess system structure before implementing changes. The software system involved are fairly large, from several thousand to a quarter million lines of code. To derive a software reflection model and iteratively refine it, the user performs five main steps or five main stages. As you can observe here from this diagram, the five main stages are define high level model, extract source model, define map, compute reflection model, and investigate and refine. Let's talk very briefly about all of these five steps. In define high level model, it describes the aspect of the system structure that aid in reasoning about the software engineering task at hand. It basically defines it, and then in the next level extract source model, the user applies a tool like a graph extractor or a file dependency extractor to to extract the information from the source code. This information forms the source model that will be compared with the high level model. Then we have the define map. Basically, in the define map, the user maps that describes how entities in the source and high level models relate. To make this map easier to state, a user may refer to information about the both physical and logical software structure. By this, we mean the system artifact, which is the source code, the documents, and so on. Then we have the compute and reflection model. Given a high level model, a source model, and a map, basically the previous three steps, the user invokes a set of tools to compute a software reflection model. The reflection model lets the user see the interaction in the source code from the viewpoint of a high level model. After we have performed the four steps, we will go into the next step and the final one, which is investigate and refine. Simply viewing and displaying a reflection model does not generally provide a sufficiently detailed information for a user to assess, plan, and perform a software engineering task. Typically, she must also investigate the source model interaction mapped to a particular arcs in the reflection model. After the five steps are performed, it is better to go back to step one and refine the process and perform it all over again. That is a general overview of the technique. We'll pass on to Avinesh now.
Okay, hi. So finally, I'll be talking about the lesson learned regarding tool-based software engineering. So there are four lessons. We'll start from the first one, which is explicit declarative maps help task performance. The engineer used the map to help isolate potential components in the source. Uh, Researchers will use this map primarily as an input to the techniques. It is used to place conditional completion statements in the source, help the isolation process. This highlights value the information that connects the overall view of the source. Okay, so the next one will be graphical and text interfaces that are needed. The researchers provide both textual and graphical interfaces for the reflection model tools. Uh, the engineers drove almost all the investigation of the reflection model and the source code from the textual information. Thus, it might be important to rethink the general belief that graphical interfaces to reverse and re-engineering tools are best approach. Next. Okay. So the third one is task-specific views are also important. The engineers involved in the case study found it is useful to be able to view the system in terms of uh, a refined reflection model. Yet, they also found it's valuable to build up an understanding of how the high-level view connected to source codes. An important side effect of this flexibility is economy, because since the engineers could keep parts of the model fuzzy and refined, only select parts, uh, they were able to avoid wasting time collecting information uh, that is not needed. Okay, so the last one is tools and process must adapt to the task. So, for example, the Microsoft engineer introduced exceptions to better support his exploration of the Excel source code. The architecture of the reflection model tools as a set of filter programs and the flexibility of our technique made these adaptations possible. The engineer's use of the reflection model tools in practice help focus the improvement of both the techniques and the tools. Uh, so that is all for our presentation.
Thank you.
Okay, thank you.